Hi, welcome to my YouTube channel Electronics for Gate by Kota Venkanna. My mobile number 630-5826-909. Today I want to discuss Gauss law. So here the statement of Gauss law is that the electric flux passing through any closed surface is equal to the total charge enclosed by the surface. That is, psi is equal to Q. So where psi is the flux passing through closed surface, Q is the charge enclosed by the surface. Charge enclosed by the surface. Here, a point charge. It is a sphere. It is a sphere. In this sphere, a point charge Q is there. Q is there. So Q is enclosed by the sphere. Here, a point charge Q is enclosed by sphere, which emanates the flux around the surface of the enclosed surface. Around the enclosed surface, which emanates the flux that is represented with psi. So here the total charge enclosed by the surface Q must be equal to the flux emanates around the surface of the enclosed surface, that is psi. So therefore psi is equal to Q. That is the Gauss law. Here a point of line charge. Here a part of line charge or a point of line charge that is Q and enclosed by the surface, and which emanates the flux around the surface, around the closed surface, that is represented with the psi. Here also Q is equal to psi. Q is the charge enclosed by the surface, and here irregular surface. Here irregular enclosed surface. In the irregular enclosed surface, the charge is there, Q, that is represented with the Q, and which emanates the flux around the irregular surface, that is psi. Here also Q is equal to psi. Q is equal to psi. This is the statement of Gauss law. So here we will see the mathematical representation of Gauss law. Here the mathematical representation of Gauss law is that consider an irregular closed surface. Here a small differential surface. This is the small differential surface ds, and d is the flux density, and here q is the total flux passing through closed surface, that is psi, and q is the total charge enclosed by the surface. Here q is the total charge enclosed by the surface, and psi is the total flux passing through the closed surface is psi. So from this irregular closed surface we can derive the mathematical equation of Gauss law, and here the surface is irregular. Here the surface is irregular. So due to the irregular surface, the direction of d and as well as magnitude is going to change. Direction of d and magnitude of d is going to change from point to point on the surface. So only due to the irregular closed surface, and here the surface ds is the vector form. Surface ds is the vector form in terms of its area and direction normal to the surface at that point. So therefore ds is equal to ds an. So here an is the representation of vector quantity. Small differential area ds is the vector quantity. So that is ds is equal ds into an. So flux passing through the surface ds is the product of the component of d bar in the direction normal to ds and d psi from the figure. So it is represented as d psi is equal to dn into ds. So here in the from the figure dn is written as d bar modulus of d bar cos theta, and this d bar cos theta is substitute in this equation, then d psi is equal modulus of dn cos theta ds. So here dn ds cos theta from the dot product formula a bar dot b bar equal to ab cos theta. So similarly ab cos theta is also written as a bar dot b bar, So that's why it is written as d psi is equal to d bar dot ds, So here this is the flux passing through incremental surface area ds. This is the flux passing through incremental area surface area ds. Hence the total flux passing through entire closed surface is to obtain by finding the surface integration of this equation. Then psi is equal integration. So taking integration for the total flux passing through the closed surface, we have to integrate this. So that's why integration of d psi is equal to integration of d bar ds bar. So that is integration differentiation both are cancelled. So that's why the total flux psi is equal to, this is the surface integration of d bar dot ds bar. So that is equal to q, enclosed charge q. So this is the Gauss law. So that is psi is equal surface integral of d dot plus d dot ds, that is q. Q is the charge enclosed by surface. This is the Gauss law, the mathematical representation of Gauss law. If there are number of point charges in the enclosed, for example, it is in the enclosed surface, there are number of charges, point charges are there, q1, q2, q3, q4, q5, q6. Then the total charge enclosed, that is equal to q is equal to q1 plus q2 plus q3 plus and so on qn. Then the psi, the flux passing through enclosed surface equal to q, that is summation of qn. And the second point, if there is a line charge with a line charge density, for example, it is a line charge and then line charge density rho L, then the psi is equal, q is equal to line integration, here line integration of rho l dl. And if there is a surface charge with the surface charge density, then psi is equal to q is equal to surface integral of surface charge density rho s ds. And if there is a volume charge with volume charge density rho v, then it is written as psi is equal to q is equal to volume integral of rho v dou v. So these are the basic definitions in the Gauss law. So then the common form mathematically representation for Gauss law is psi is equal to q is equal to surface integral of d bar dot ds is equal to volume integral of rho v dv or dv. So this is the general form or common form for the mathematical representation of Gauss law. Next we will discuss the applications of Gauss law. So here these are the applications of Gauss law. Gauss law is useful to find the flux or flux density from the knowledge of enclosed charge and surface. Here the psi is equal to q is equal to surface integral of d dot ds or volume integral of rho v dou v. So here it is useful to find the flux psi or flux density d from the knowledge of enclosed charge and surface. So here from this equation, this is the Gauss law statement equation. So from this equation, if you know the value of d and if you know the value of rho, it is easy to find out q and it is easy to find out psi. And second application is, it is useful to find the electric field from the knowledge of enclosed charge and q. So here if you know the value of q, it is easy to find out d. So from the equation d is equal to epsilon into E. So if you know the value of d, then it is easy to find out E, electric field. So electric field is, if you know the value of q, by using q it is possible to find d, and it is by using d it is possible to E from this equation. And third application is, it is useful to find enclosed charge from the knowledge of either d or E. So from the third application, if you know the value of d or E, it is easy to find out q, enclosed charge. So if you know the value of E, then it is possible to find d. If you know the value of d, then by using this equation it is possible to find q. So these are the basic applications of Gauss law. And next we will see the limitations of Gauss law. We will see the limitations of Gauss law. Now the limitations of Gauss law. It cannot be, first limitation of Gauss law is, it cannot be applied on Gaussian surfaces. So it is applied only on Gaussian surfaces and it cannot be applied on Gaussian surfaces. This is one of the limitation of Gauss law. And second one is, it can be applied only if the surface encloses the volume completely. So if the volume is completely enclosed, then it is applicable. The Gauss law is applicable. And if the volume does not completely enclosed, like this and like this and like this, then Gauss law is not applicable. So the Gauss law is applied only if the surface or volume is encloses completely, then it is applicable only for Gaussian surfaces and does not useful for Gaussian non-Gaussian surfaces. So these two are the limitations of Gauss law. Thank you for daily classes, and for any updates subscribe my channel. My channel name is Electronics for Gate by Kota Venkanna. Thank you.